Okay, let's jump right in. For, for a long time, when we thought about black holes, the picture was pretty simple, right? These giant cosmic vacuum cleaners just sucking everything in.
Exactly. Static. But the sources you sent today, they just completely blow that picture apart.
They really do. We've just caught a supermassive black hole doing something, frankly, incredible and terrifying. We actually watched it erupt in real time.
It was a true cosmic spectacle. We're about to dive into the hidden, the violent forces that drive these massive expulsions of matter.
And the mission of this deep dive is critical because what we're looking at here fundamentally challenges astronomy's long-held theories about how these monsters manage to push matter out.
Right. And the star of the show today is a supermassive black hole in a galaxy called NGC 3783.
NGC 3783. And the sources are pointing to this huge breakthrough. Because for decades, the conventional wisdom, the thing everyone believed, was that when a black hole ejects material, the engine behind it is, it's just intense radiation pressure.
Basically, the sheer force of heat and light pushing gas away.
Exactly. But the core finding here, it just rewrites that entire rulebook. Researchers saw this ultra-fast outflow of matter, and the data was so clear, so precise.
Incredibly precise. They could conclusively identify the driver. And it wasn't a gentle push from heat. It was pure, sudden, explosive magnetic energy.
Yeah, that distinction, radiation versus magnetic fields, that changes everything, doesn't it?
Everything.
Because if you're wondering why you should care about the difference, consider this. This discovery radically alters how we understand a black hole's real role in the whole cosmic ecosystem. We're talking about the very mechanism that dictates how galaxies grow and evolve.
If the magnetic field is the true regulator, then every black hole is sort of a hidden sculptor of its own galaxy. We're really delivering the aha moment in astrophysics here.
Okay, let's unpack this. Because catching an event like this, it feels like trying to photograph a lightning strike. But on Mars, the effort to get this view is just staggering.
Oh, it was an incredible logistical feat. This wasn't one telescope. The campaign was led by an international research team from ESRON, and they managed to pull off a record-setting, uninterrupted 10-day monitoring period, just focused squarely on NGC 3783.
And that continuous surveillance is so key, isn't it? You have to be watching when the thing actually goes off.
You do. And the main instrument, the one doing the heavy lifting, was the new Japanese space telescope XRI-XIMM. It specializes in measuring X-ray spectra with amazing precision.
But the sources really emphasize that the collaboration was the real story here.
Absolutely. The astronomers needed comprehensive data, across the entire electromagnetic spectrum. We're talking about a global array of X-ray scopes, XRI-XIMM, XMM Newton, Chandra.
So all the big ones?
All the big ones. And they used that to analyze the outflow's energy signature. But then they also supplemented that with optical data from Hubble and real-time monitoring from SWIFT and NICER.
So instead of just a list of acronyms, think of it like this. They turned 7 highly specialized space instruments into one giant synchronized cosmic camera and a thermometer.
That's a perfect way to put it. They used every tool they had to make sure they didn't just see something move, but that they understood the physical force that was moving it.
And that coordination is what gave them the clearest view ever obtained of one of these turbulent black hole cores.
Precisely. That clarity was what they needed to really distinguish between the two competing theories.
Okay, so they've got the perfect setup. 10 days of surveillance. What did they actually see?
Well, throughout the observation, XRI-XIMM was recording the usual stuff, these slow fluctuations in soft X-ray brightness that are typical for active galaxies, just the expected jitters.
The background noise.
Right, the background noise from gas swirling around. But then on the third day, the whole system just detonated.
It's the moment of the eruption.
Yes. One particular outburst just stood out. It lasted for about 3 days, and it unleashed this massive ejection of gas right from the inner accretion disk.
And the numbers are what get me. If you're trying to figure out what engine could be powerful enough for this, the velocity is your first huge clue. The ejected matter hit speeds of 60,000 kilometers per second.
60,000 kilometers per second? That's nearly 20%. 1/5 the speed of light. It's just conceptually so difficult to grasp.
It really is. To put that in perspective for you, a flight from New York to London at that speed would take about 0.15 seconds. It's an almost impossible velocity for matter that's trying to escape a region dominated by extreme gravity.
That speed alone immediately calls the old rulebook into question. And what's more, the researchers were able to trace the ejected matter back to where it started.
And where was that?
a specific area located about 50 black hole radii from the core.
Okay, wait, let's pause on that. We should probably demystify that jargon. What exactly is a black hole radius, and why is that number 50 so crucial here?
Good question. Think of a black hole radius as just a unit of measure that's scaled to the black hole itself. So 50 radii just means 50 times the distance of its event horizon. And this specific location is sort of the Goldilocks zone for this discovery.
The Goldilocks zone. Why?
Well, if the gas was closer in, say 5 or 10 radii, gravity and the heat from the accretion disk would be so overwhelmingly strong that, yeah, that energy source would have to be radiation pressure.
Okay.
And if it was much farther out, the forces would be too weak to accelerate the matter to that kind of extreme velocity. So 50 radii out is the sweet spot. It's where the magnetic fields, which are twisting and storing up energy, can suddenly become the dominant explosive force.
A force that can actually overpower gravity and the radiation pressure.
Exactly.
So this is where the old theory officially gets rewritten. You see matter moving at 1/5 the speed of light, and the old explanation, radiation pressure, just can't do that. You need a different kind of engine.
You need something capable of an instantaneous explosion, not a continuous push. Radiation is like a gentle, constant wind pressure that slowly accelerates something.
Right. It can't account for that sudden, violent acceleration they saw.
It just can't. The data revealed that the engine driving this had to be purely magnetic energy.
So what's the specific magnetic mechanism then? What's powerful enough to do that?
The team concluded it was a process they call magnetic reconnection. To visualize it, imagine the magnetic field lines near the black hole are like these colossal stretched rubber bands.
Okay.
Because the black hole spins and all the gas is swirling, these field lines get incredibly twisted and tangled up over enormous distances.
So they're storing huge amounts of potential energy, like a bowstring being pulled taut.
Precisely. And at that 50 radii mark, the stress just becomes too much. The field lines snap. They violently break and then reconnect into a new, simpler shape.
And that snap is the explosion.
That's the explosion. That sudden release of stored magnetic energy is what instantly propels the gas outward. It's like a massive short circuit in space.
Wow. That's an incredible visual, and it explains the instantaneous acceleration. The lead author, Li Gu, described this as a rare opportunity to watch a black hole ignite an ultra-fast outflow. So we didn't just see the fire, we identified the match.
And what's so fascinating is the cosmic doppelganger effect here. This huge magnetic event is strikingly similar to things we see much closer to home.
Like what?
Solar flares or coronal mass ejections, where our own sun hurls plasma out into space.
Wait a second, that's a huge point. If it's the same basic physics magnetic field snapping, why did it take us this long to realize a supermassive black hole could be using the same trick as our sun?
It's mostly about scale and an assumption of dominance. For a long time, the gravity and the just blinding luminosity of an active black hole were seen as the only forces that mattered.
Magnetic fields were just a sideshow.
A secondary effect, yeah. But now we realize that these magnetic fields, while complex, can store something like 10 billion times the energy of a solar flare and release it just as efficiently.
So a supermassive black hole is basically having a magnetic tantrum, one that mimics the sun but on this vast universe sculpting scale.
It introduces a powerful new model for black hole behavior. These magnetically powered eruptions might explain the mysterious, quick variability we see in countless other active galaxies. It repositions magnetic energy from a supporting role to a starring role.
This realization that it's magnetic storms and not just heat driving these things, it has huge implications. Let's talk about the big picture for you, the listener, the impact on how galaxies evolve.
It matters for everything you see in the night sky. Understanding how black holes eject matter is so crucial because these outflows aren't neat little jets that just vanish. They fundamentally reshape their surroundings.
They're injecting huge amounts of energy and mass back into the galaxy.
A ton of it. So the black hole, which we all thought was just a celestial vacuum cleaner, is actually acting more like a giant, violent thermostat for the entire galaxy.
That's a perfect way to put it. This whole process is what scientists call black hole feedback, right?
It is. These massive, ultra-fast ejections, they redistribute gas. They can prevent it from cooling down in some areas, which stops stars from forming, or they can push it into denser zones and actually accelerate star formation.
So the magnetic outflow is a regulator? It dictates the rhythm of the galaxy.
Exactly. This event shows that black holes can both feed and starve their galaxies through these magnetically powered eruptions. If this hot, ejected gas prevents cold gas from collapsing, boom, fewer stars form.
And that helps explain so many of the odd things astronomers see, like why some massive galaxies just seem to stop making stars, even though they have huge reserves of gas.
It's a mechanism of cosmic self-control, and it's driven by an engine we just finally confirmed we can see in action.
Which leads to the big question the sources raised, and it's one we all need to think about. If this process, magnetic reconnection, turns out to be common,
Then how many other galaxies out there are being silently sculpted by these hidden magnetic engines that we simply haven't been lucky enough to watch during that brief moment of eruption?
it puts magnetic energy in a totally new light. It's not a footnote. It's a dominant, universe-sculpting force. We've gone from seeing black holes as just defined by their gravity to understanding them as engines. Engines driven by these vast, solar-like magnetic storms.
And that extreme velocity, that 20% of the speed of light, that's the fingerprint. It's the clear marker of a sudden explosive energy release. It proves that magnetic fields are powerful enough to dominate both gravity and radiation at these critical distances.
And finally, let's just circle back to the sheer coordination that made this happen. Those 7 different space missions, all pointing at the same spot at the same time.
I mean, that level of collaboration shows that these rare, instantaneous cosmic secrets events, once thought too fleeting to ever catch, are now squarely within our reach.
We can do it now. We have the tech and the global capacity to pivot all these instruments onto a single, rapid event and gather all this complex data in real time.
We really do.
So the provocative thought to leave you with isn't just about the magnetic fields themselves, but about the future of discovery. What other fundamental rapid-fire cosmic mechanisms, things once deemed unknowable because they happen so fast, are just waiting to be uncovered by these globally coordinated campaigns?
Right, whether it's a black hole igniting or the final moments of a dying star or maybe the birth of a new magnetar, this new era of global cooperation is changing what we even believe is knowable about the universe. So, keep watching those X-rays.
For the complete news, visit our website. Support us by following and sharing.